We're going to be talking about sample loading techniques for flash and prep HPLC and techniques to mitigate the sample loading effects on chromatography. There's my contact information there. If you guys have any questions, feel free to ask during the talk, and we'll answer them at the end. So the outline for what we'll be discussing today is what theoretical impact does loading have on a separation? So how does it affect the chromatography? How to choose and implement sample loading techniques in flash chromatography, such as how much sample can I load? Should I do liquid loading or solid sample load cartridges? Then we'll discuss considerations and limitations that apply for sample loading in prep HPLC, and then how we can increase prep HPLC throughput using automation techniques. So fundamentally, how does chromatography separate compounds? We have two phases: a mobile phase and a liquid mobile phase, and a stationary phase that consists of our column packing. And ultimately, what we're limited by is our sample solubility. So we need to determine the best way to get our sample into solution and to get it to travel down the column. And so we can think about the interaction between our compound with the mobile phase and the stationary phase based on this nice graphic here. It shows how our compound interacts with the different mobile phases, in this case, an alcohol and water, and then the C8 chains off the functionalized silica there, the stationary phase. And so it's driven by the interaction between the mobile phase and the stationary phase. In normal phase, we would have no functionalization on the silica traditionally, and we'd be using normal phase solvents like hexane, ethyl acetate, or DCM, something like that. And then reverse phase, we have the functionalized silica, C8, C18, and then we're using a water with an organic modifier in the reverse phase. The important thing to realize from this is that our loading conditions can change the local mobile phase composition and change how our compound behaves. Change how the compound behaves with its chromatography. So how does loading affect your chromatography performance? The sample liquid volume loaded creates a band of sample, and this loading band is kind of the minimal peak dispersion, and it's inherent to the separation. The dissolution strength can cause the compound to begin traveling down the column. So what happens is if you have a really strong solvent we're loading it on, and it's stronger than our initial mobile phase, then your compound's going to start to travel before the weak solvent begins to dilute the strong solvent, and we get travel down the column. This causes band broadening and then decreased retention of our compound, and so poor separation. The loading conditions could create a mobile phase environment that's stronger than your starting gradient conditions, as I just described there. And the compounds that have a lower retention in the mobile phase or sample solvent are more affected. So compounds that elute earlier in our gradient are more affected than compounds that elute later in our gradient. And so this causes a decreased opportunity for the compound to interact with the stationary phase, and basically causes you to have less usable column volume size for your separation. So one question is to think about what your ideal loading conditions would be. And so one, we'd have a sample that's well soluble in our solvent, and that it's weaker than the starting gradient composition. So if I was in normal phase, it would be something that dissolved well in hexane, and that's my weak solvent composition in a hexane ethyl acetate gradient. And so it's well soluble in that. A lot of times that's not the case. And in the reverse phase, it's soluble in water, and we load it, and that's a weaker injection than our starting gradient. The next thing is that our compound doesn't begin traveling down the column at the beginning of the run. So basically, it's a compound that is sitting at the top of the column until all the sample band is absorbed, and it doesn't start traveling until we reach a certain %B in our gradient. That's higher than our starting composition. The reason for this is it maximizes the amount of column that can be used in the absorption, desorption of the compounds, and that's what drives your separation. This results in a nice tight band at the top of the column and gives you optimal chromatography throughout the rest of your run. So that would be the ideal conditions. A lot of times we're not able to do those things, and we're going to discuss how we can compromise to have good chromatography and be able to load our sample in as much as possible onto our columns. So we'll begin first by looking at flash loading techniques and guidelines. So far, first question is how much sample can I load onto a flash column? And you really need to ask yourself, how much sample do you have? And then you'd be deciding which column you'd want to use. So for bare silica, we'll go into a few more details, but you can load anywhere from 1 to 20% of the column size based upon your resolution of impurity, so how close your impurities are to your compound and in your method, and then the stationary phase that you're using. So are you using a normal ready step or gold ready step, which we'll talk about in a little bit. If you're using a functionalized media like C18, C8, some of the mean columns or things like that, then the loading is less because that functionalization takes up some of the column space you have for interaction. So you'd be loading anywhere from 0.1 to 2% of the column size for functionalized media like C18. We talked about the difference in media types. So if you have a spherical particle that's smaller, you get better packing, get better separation. You can load more compound with our ReadySep Gold material versus the regular ReadySep, which is larger and it has irregular particles, which doesn't pack as well. So you're able to double the loading size using ReadySep Gold. It also offers twice the resolution power also. So as a good reference for how much sample you can load, here's a table of different column sizes and the loading that you can do based upon the resolution of your run. So if you have delta CV of 6, or a difference in column volumes of compounds, and this would equate to about 2 to 3 or 0.2 to 0.3 RF separation from any impurities. You could load up to 20% of your compound onto that silica. So if I had a 4-gram column, I could load 800 milligrams. If I had a 80-gram column, I could load 16 grams of compound onto that column. If it's an easy separation and I'm not using gold media and I'm using regular ReadySep, then I would load half of that. So if I was using my 4-gram column, I could only load 400 milligrams, or 80-gram column, I could load 8 grams. And then if it's a difficult separation where the column volume is less than 1, so we're talking about very, very close RF values, then you'd be loading about 1% onto that silica column. So if I was running a 4-gram column, I'd load 40 milligrams, and on the 80-gram example, 800 milligrams. So as my separations become more difficult, I'm able to load less compound, and I would need to scale up to a larger column to be able to get that same separation. Well, the next thing is to think about is what kind of solvent am I using when I'm loading my compound. So ideally, we said we'd be using a weak solvent to load our compound, or no solvent at all, to really minimize that initial band. So if we think about our solvent selection chart, you can look at the different solvent strengths in parentheses there, and you can see, the higher the number, the stronger the solvent strength, the more it's going to travel down the column. This is for normal phase. So, compound or solvents like ethyl ether are a good choice because they have a lower selectivity value or solvent strength value, so you're able to dissolve compound and not really travel down the column. As you move to the acetone or ethyl acetate or your alcohols, those solvent strengths go up, and that causes problems. The ideal case would be, like I said, if you're in a hexane gradient, using hexane as your base solvent, that would be your ideal conditions. But a lot of times that doesn't dissolve your compound very well. So ether, DCM, those are good choices to load your compound while minimizing your band broadening. Another simple chart way to look at this is, the solvent strength here for hexane, toluene, diethyl ether. all the way up the chart to methanol there. So you can kind of see the relative solvent strength. And you want to really work on the lower values there. This is for normal phase. For reverse phase, water, 100% water is going to be your best solvent. And basically percentages of water, increasing the percent of alcohol in the water is going to cause it to start traveling down the column. So you want to minimize the amount of organic modifier that you use. A lot of times people like to use DMSO and things, which we'll talk about a little bit later. So your guidelines for liquid injection. So ideal case is that we don't have to dissolve our compound in anything, and we can do a neat liquid sample injection onto our column. A lot of times that's not the case. So we need to then dissolve the sample and then add directly onto the column after equilibration. Same rules as traditional open column chromatography. You want to minimize the amount of solvent because that's going to be your inherent band width. And then the weaker the solvent, the better. And you can see here, here's an example of a strong solvent versus a weak solvent. And you can see the band broadening from the strong solvent, both visually and in the chromatogram there, versus the weak solvent here. So this is a C18 column, and this was loaded in alcohol versus the water solvent. Keep in mind the water is able to dissolve it though. As an alternative, we get limited, by the solubility of the sample. So we don't really want to use a strong solvent to load onto the column because we know that it's going to cause the column or the compound to travel and decrease the efficiency of the column. The method to mitigate that is to do a solid sample load. And this is something that's really easy to do on our CommaFlash next gen units. And we'll show a video here in a little bit showing how to do that. But basically, with solid sample loading, your guidelines are as follows. It's simple to use. Basically, you pack the cartridge and then you seal the cartridge with the adjustable cap and place it on the system. The caps are designed to minimize any dwell volume and to minimize any extra effects on the chromatography. This is really great for hard to dissolve compounds that would require large amounts of strong solvent to do a liquid injection, and it results in optimal chromatography. So good resolution, and it minimizes your band broadening when you dry it. If you don't allow that column to dry completely, then you may have poor results because that strong solvent's still on there and it's causing some compound to travel down. It's still better than a purely liquid injection though. The other thing is that this cartridge can act as a pre-column. So this is really good for helping to prevent precipitation of any impurities at the column head and prevent clogging at the column head. And then also if you do using reusable columns like C18, this helps protect that column because none of the particulates are able to get to it. They're on the guard column instead. The other thing is that it does increase the effective column length through the extra silica or your packing material, C18, if you're using that on reverse phase. And so that does cause a slight delay in retention, but overall that's going to increase the effectiveness of your chromatography. So something to keep in mind is your compounds will come out a little bit later by half CV to a full CV, depending on how much media is in the cartridge. So there's two types of solid load cartridges that you can use. You can pack them yourselves. And to do that, you basically have an empty solid load cartridge. You would weigh your sample, and if I had 5 grams of sample, then I would load that would be determine how much silica I would need. So I would need to be using about 25 grams of silica to load that onto my solid load cartridge. So I have to choose the appropriately sized solid load cartridge and add about 25 grams of silica to that sample. If I was using C-Lite, I would be loading more C-Lite in there, so I'd use 50 grams, which is an alternative you could use. And then dissolve the sample completely in a strong solvent. So whatever is going to dissolve my solvent, I dissolve my sample in. I'm going to use as my solvent. I'm going to mix that with the silica, and then I'm going to go put it on the rotovap and dry it off. Once that is dry, it's going to be very powdered. and then I can go ahead and load that onto the solid load cartridge once I've removed all the strong solvent. One of the cool things on the, about our sample load cartridges is that that frit fits well inside the bump trap of the rotovap for a 2440 adapter. And so you can use that to keep the silica from bumping into your bump trap. So you can place that into the bump trap while you're evaporating the solvent from the silica. Once you go ahead and place your sample into the cartridge, you would then add the top frit to it, pack it with the packing rod, and then insert the solid load cartridge cap. And we'll show a video for that in a second here. Once you have your packed cartridge, you can go ahead and then load it on the system, which will show a video in a sec. The other alternative is to be coming from a pre-packed solid load cartridge. And in this case, the cartridge is already packed with material such as silica or C18 is what we offer. And basically it's already got the frit in place, the top frit in place. And what you're doing is you're going to load your liquid sample onto that cartridge. So if I chose, like I said, a 5-gram sample, I would choose a pre-packed 25-gram cartridge. I would load my sample in a strong solvent onto that cartridge, and then I would let it dry. And you could dry it using house air. You could put it into a vacuum oven, or you could just let it set in the hood for a few minutes, depending on the volatility of the solvent you loaded. So if I used ethyl acetate or something like that, I could just let it sit in the hood for a little bit, and it should be sufficient to kind of evaporate that off. And we want to try and get as much of that solvent off of the silica as possible. And we'll show some examples of what happens when we don't do that. Once you've done that, go ahead and load the sample load cartridge. So I'm going to show a quick clip here of how to load the solid load cartridge onto the system. So hold on one sec. Okay, so in this video, my colleague Mark Dodsworth is going to show us how to use the solid load cartridge on the next gen here.
So now that we've prepared our dry loading cartridge, all we need to do is load this with our column onto the machine, and we're ready to run our purification. So let's give that a go. First, we need to remove the bypass tube. We then lift the valve up and insert the column. The machine will detect that this is a 24-gram silica cartridge. We then take the dry loading cartridge and load this onto the top of the injection valve and screw this into place. We then use the tubing to connect to the top so that after the equilibration is done, the system will divert the flow through the bulkhead, round this tubing, through your dry loading cartridge, load your sample that you've prepared directly onto the top of the column for the purification. We're then ready to set our gradient up on the system in order to run our sample.
Okay, so as Mark explained there, that's how we can, that's the process for loading the cartridge onto the column. One of the things you didn't see there is when you're selecting on the system, you're given the options of doing a liquid load, solid load, or solid load with pause. And so the solid load with pause allows you to go ahead and, if you've already prepared your sample, or sorry, if you haven't prepared your sample, it'll pause the system after it does equilibration until you tell it it's ready to go. If you do solid, choose the solid option, what is going to happen is that it's assuming that you've already put your sample cartridge on there, and it's going to bypass flow to the cartridge after the equilibration step automatically. So it's going to continue right away. So those are two key things to kind of realize there. If you do liquid, what it's going to do is going to wait for the equilibration to get done and then ask you to inject the sample. So to kind of see the results of some different techniques in the solid load cartridges here, we've got some examples of some samples here run using a user pack column, the pre-pack column, and then doing liquid injection. And then also doing pre-pack columns and not drying them properly. So the first example is probably the best example, is that your user packed solid load cartridges. This is going to offer you the best resolution. It also gives you some flexibility because you can use other media such as sea light, charcoal, or other scavenger resins that maybe allow you to enhance your purification technique. So maybe if you're using a scavenger resin, you can get some more of those impurities off of that kind of stick to the resin and don't even make it down to the chromatography on your column. So that improves the effectiveness of your chromatography. You need to match your sample size to the silica for loading, like we discussed before. So you're about 20% loading onto your silica. And keep in mind that's a different value than what your column is. So if I'm loading 20% onto that cartridge, that's added onto the column size that I'm using. So it allows you to use a strong solvent to dissolve your sample. So we don't have dissolution as a problem. It acts as a pre-column and it prevents clogging from the precipitated sample. If you were to be purchasing these cartridges, these are called empty solid load cartridges. And you can see the chromatogram here. So we get clean separation of the two peaks. If you look at the HPLC of the two peaks of each fraction here, you can see that we get clean separation of the two compounds. So this is a great example of the user packed solid load cartridge. Now, if we do the pre-packed solid load cartridge here, so we have two examples here. One is when the sample has been completely dried on the cartridge, and then one where the sample wasn't completely dried. So we've loaded it with strong solvent onto the pre-packed cartridge. We dried the sample in the cartridge completely, and we're able to get good separation. The resolution is not quite as great as the user packed, but you still get good clean separation between the two compounds. We get baseline resolution, which is great. When we don't dry that cartridge, though, in the second bottom example, you can see that we get coelution of the peaks, and there's peak overlap there. So we don't get the baseline resolution, and you can see that there's more of an impurity in both of those fractions there, and that's not going to be great for our separation when we have close eluting compounds. So that shows the importance of being to dry that sample completely on the cartridge and get rid of that strong solvent so we can get the best purification. And then finally for liquid loading, so if I were to load this compound in a strong solvent here, you can see how now we've got basically some peak fronting on that first peak. We don't get baseline resolution. There's really poor peak shape on the first and the second peak there, and we're not getting a good separation of compounds and basically a purification that we'd have to probably redo. So, but that's liquid loading with a strong solvent. So keep that in mind. If we had a weaker solvent, we could get better resolution there if it was able to be dissolved in that weak solvent. We're going to go through some examples in the reverse phase for flash using C18 as an adsorbent for the solid load cartridge. And so we have pre-packed, and you can also use your own C18 media in the user packed cartridges or the empty cartridges. And so basically, if you're using the pre-packed, we do need to condition that C18. And so we want to wash that with organic solvent followed by water. And then we dissolve the sample in a minimum amount of water to load it onto the cartridge. And so we would then insert the solid load cartridge. So you're not going to be drying that like you would on the normal phase. So the C18, you need to precondition your cartridges there. If you're using the self-packed, then you would follow the same procedure for the silica, where you would evaporate on the rotovap and remove the solvent as best that you can. The neat thing about the C18 solid load cartridges and a reason to use them when you're using the reusable C18 flash columns is that it acts basically as a guard column to extend the life of your flash column. Because these columns are reusable in the reverse phase, you don't have the swelling of the column body with the extended solvent use. To reuse it and to prevent degradation of the column from particulates and things like that, you can use a guard column instead to help extend the life of it. So it's a really good use of it. So here's some examples using the C18 solid load cartridge. It's important that when we load these onto the cartridge, we're using a minimum amount of strong solvent. And these examples are showing why. So if we dissolve the sample in a minimum amount of strong solvent, we can get good resolution between the peaks in the first top example. But as we increase the percentage of strong solvent in the dissolution solvent, you can see that we start to get coelution and we don't get baseline resolution on the C18 column there. Another alternative, and you can use this in reverse phase or normal phase, is to use C-Lite as an adsorbent on the solid load cartridge. And C-Lite's basically a type of silica. It has reduced adsorption or binding compared to our traditional silica. And you can use it with either reverse or normal phase. Just keep in mind water is the weak solvent for C18, but the strong solvent for silica. So we would want to dissolve it in water for reverse phase applications, and then use a solvent like hexane or something, or stronger solvent like, if we're going to evaporate it, like ethyl acetate or something like that for normal phase. And then we can go ahead and evaporate it like we described before for the user packed columns or cartridges, sorry. The compound's in a loop from the C-Lite. They don't really have any retention on the C-Lite, and then they're going to see retention on the C18 or your silica. If you were to do a liquid injection onto the C18 column, you'd be loading a lower percentage relative to what would be loading in the silica column. So the C18 columns, you're loading about 1 to 2% of compound based on your resolution. Diluting the sample in a large volume of your weak solvent is better than concentrated sample in a strong solvent. The column will capture the compound in a weak solvent. So basically it's just kind of sitting on top of the column as you're loading it. It's not traveling down. But as you start introducing strong solvent, so if you're using like DMSO or methanol or whatever your strong solvent is in the system, it'll start traveling down the column, and that's going to give you problems. Here's some examples of liquid injection onto the column. You can see we dissolve it in the minimum amount of strong solvent. We get good resolution, baseline resolution between the peaks. And then as we increase the strong solvent doing the liquid injection, basically, you can barely see that there's 2 peaks there, and there's coelution. So to kind of summarize the different sample introduction technologies and techniques that you can use for flash. So we have the solid pause or solid ready to go on the next gen, and then the liquid option, and then the none, the direct on column. So the solid pause offers you, you're able to do low solubility samples. It's repeatable. There's no carryover between runs, and it's 100% sample transfer. You're not losing anything. You don't have to push any solvent through afterwards to inject it. It gives you a nice tight loading band, filters and removes baseline material, and offers improved separations with a longer bed because you've increased the amount of media there. It also increases the life of your reusable C18 columns. So those are kind of some of the highlights there of why you would choose to do solid sample load cartridges instead of liquid loading or directly loading compound onto your column. So we're going to transition to prep HPLC loading issues, and some of these issues are going to apply. We can carry over from flash here. So, but there's also going to be some differences. So obviously you have increased resolution compared to flash using the prep HPLC methods. You're limited to liquid injection techniques on the prep system. There's no solid sample loading option. And one of the limitations is in most applications of the prep HPLC, you're limited by what your sample loop size. So if I have a 5 mil sample loop, that's the maximum amount I could inject. And actually it's a little bit less than that because I don't want to lose sample out the back end of it, which we'll talk about a little bit. But that kind of gives you an overall maximum on how much you can load onto the system. And then obviously the auto sampler feature increases some loading capabilities, and we'll discuss how that affects it. The next question for prep HPLC, like flash, is how much sample can I load? And because traditionally we're working in the reverse phase, we're limited to 0.1 to 1% loading. So if I'm working on a 20 millimeter column, 20 by 150, I've got about 28 grams of media in there. And this is a handy little guide for you, but you'd be loading about 28 to 280 milligrams onto that column, depending on your resolution. So, that you can just use that table as kind of a good quick reference there. It's a little bit It's useful because a lot of times you're not used to using the amount of media inside the prep columns isn't initially always available right away. So it's a good little guide to have on hand. The next question is how much sample can I load based on volume? So how much, once I dissolve my sample, how much can I load? And so this is based on the loop size. And so there's different sizes available from Valco. On our AccuPrep is a 5 milliliter standard loop, but you can get smaller 100 microliter, 1 milliliter loops. And with these smaller loops, you can't load above 50% of the loop size using manual injection, using the auto sampler or auto injector, because you're going to start to lose sample out the backside of the loop because you get a laminar flow profile. So you can't go above 50% of the loop size. If I have a 1 mil loop, I can't inject more than 0.5 milliliters. 100 microliter loop, I can't inject more than 50 microliters. For my 5 mil and larger loops, I do have increased loading capacity because the flow dynamics change in that tubing. And this allows you to dissolve your compound in increased volume of weaker solvent potentially and improving your chromatography that way. And because sample recovery is paramount in prep, you can fill up the 5 mil loop to 4 milliliters and not lose any, and you have negligible sample loss due to the loading effect if you're using an auto sampler module. If you're not using an auto sampler module, if you're doing manual injection or using the auto injector, then you're not able to do that, go above 50% of the loop size because you don't have air or the auto sampler introduces air cushions to prevent mixing of the streams. So that's an important note and benefit of the auto sampler module is it does increase your loading capacity. If you're doing manual injection, like I said, only 50% of the loop size due to the introduction of operator variance, and you're not getting the air sample or air cushion between your sample and the mobile phase. So how can sample loading affect prep HPLC? Considerations for your loading solvent. Like for flash, it's a compromise between good dissolution while minimizing the effect on integrity of the chromatographic separation, right? So a polar compound, this is a polar compound dissolved in DMSO. The top is a 1 milliliter injection. You can see the DMSO peak here is that first peak, and then we get baseline resolution between the next two compounds, which are both fairly early eluting compounds. As I increase the amount of DMSO, though, if I increase that injection volume to 2.5 mils, you're going to see that second peak, the first peak of interest starts to co-elute with the DMSO peak, which is the first peak there, and we're not going to get good resolution between peaks 2 and 3. If we do the same separation in water, we're able to get good resolution and in good separation. So in that top example on the right, it's dissolved in 2.5 milliliters of water. And I'm actually able to increase the load up to 4 mils of water, that same concentration. And I'm able to load more compound in that 4 mils of water than I am in that 2.5 mils of DMSO. So I may be loading more volume, but because it's not contributing to any chromatography, it's just sitting at the top of the column while it's getting loaded, and then it's able to travel down the column once we get that mobile phase gradient started. But with DMSO, it starts to actually do some chromatography on the column and move down the column, and I lose some effectiveness. So notice the shark fin on the prep HPLC, that's typical of overloading, and that's okay. We still get baseline resolution because we have good separation here. So the next part of the talk, we're going to talk about some of the benefits of the auto sampler and how they help to increase loading capabilities in your throughput. And the auto sampler features that maximize loading capabilities is one, it automatically brackets the sample with air gaps to prevent mixing of the sample stream with solvent. And this decreases your initial band broadening upon loading. It also increases the loading capacity you can use based on your sample loop, as we previously discussed. So it prevents mixing with the mobile phase before it gets onto the column. Second, it increases the injection volume, as I suggested before, and we don't lose any sample out the back end of the sample loop. You also have the ability to do bracketed sample injection with the auto sampler. And so we can dedicate one of the a tube next to the wash station basically to a solvent to sandwich our sample in the mobile phase. And we can do a couple different things to benefit our chromatography. So if you're using, if you have a compound that's, liable to crash out in your mobile phase starting conditions, using a DMSO, strong sample like DMSO to bracket the sample helps prevent that. So you could choose to do the bracketed injection and then use DMSO. And basically you're going to get a sandwich between the mobile phase of the mobile phase, air, your bracketing solvent, your air, your sample, your air, your bracketing solvent, air, and then mobile phase. And that prevents the compound from crashing out before it gets onto the column. So that's a good thing for compounds you have solubility issues with. The other way you could use it is if you're using like a weak solvent like water, you could actually use water as your bracketing solvent, and it'll actually cushion the DMSO that you've dissolved your sample in and help prevent band broadening as you load that DMSO on. So that's just another way to use it. If you're not having problems with dissolution and your compound crashing out, you could choose to use water to help sandwich that and improve your the peaks in your chromatography. Some other features that are great, the auto sampler that increase your throughput. We get automatic washing and priming of the sample lines for clean and accurate injections. Since we're limited to the loop size, we can run multiple runs of the different different or the same compound without any user attention. So I can optimize my method and say, hey, I need to run this 20 times, and it'll run it and get your sample pure without any input from you, other than making sure that you got enough solvents to run the methods. And so we can do these multiple sequences, and it frees up time for the scientist with unintended operation. And then finally, we have multiple auto sampler options. We have a 2x2 and a 4x2 auto sampler, and the 4x2 is shown on the side there, and the 2x2 was shown on previous slides there. But this increases your fraction capacity. It also allows you to customize, your prep HPLC system to fit your space with a different size footprints. This is great open access and for walk-up use. The system queue feature allows you to dedicate a separation to a specific rack with ease. So you can put your own personal rack on there. Say, yeah, I want to use just rack C, and move on. And then when it's done, you can pull it off. It allows you to customize the injection parameters, the method parameters for individual runs without any issues while the system's running. Really easy to use. Multiple sample rack options. We have full and half rack sizes, and multiple sample introduction sizes here. You can 13 millimeter tubes, 28 millimeter scintillation vials, or even 125 milliliter square bottles for really large throughput on large columns. So a lot of different options to, for your unique applications and needs for your lab. So in summary today, we worked through how different loading decisions affect chromatographic processes. We described the ideal loading conditions. We've discussed several factors to consider for liquid loading and solid sample loading for flash chromatography, and how to use the solid sample load cartridge. We've showed examples of different loading techniques and how to minimize affecting the chromatography in prep HPLC and flash. The different techniques you can use on the auto sampler to minimize degradation to your prep HPLC separations during loading, like the sample bracketed solvent sandwich function there during injection, and then also how we cushion the injection with air using the auto sampler, and that's not something you're able to do manually or with the auto injector only. And then how combining an auto sampler with the AccuPrep HPL 150 increases your throughput and frees up your scientist time. It's a quick summary of some of the combo flash chromatography systems. We've got the next gen 300, 300 plus, and 100. you know, our pure ion mass spec that kind of goes on in any of our systems, the Easy Prep and the Torrent and Torrent AQ. And then you pictured before was the AccuPrep, so our Prep HPLC system. So a lot of great options for different stages of your purification, depending on your scale and your needs, and you know what kind of processes you guys are doing on a daily basis. Feel free to download a copy of our guidelines and tactics for flash chromatography. If you go to our website and then click on the flash guide, you can download that, and there's a lot of great information that's pertinent to flash and then just chromatography in general in that guide. And at this point, we'll open it up to questions. We'll answer your guys' questions. If you have any questions that come up later, feel free to reach out to me directly at my email, joshua.lovell@teledyne.com, and I'll be more than happy to help you out.
Okay, thank you, Josh, for sharing your expertise on this topic. We do have several questions that we have received. If you have further questions, please be sure to ask the questions via the Q&A section within Zoom. By doing this, this allows us to pull a report, and that way if Josh needs to contact you after the webinar to provide further information, he would be able to do so. Our first question, Josh, is how do I load a sample in low volumes, example 1 milliliter, without spilling a lot of it on the CombiFlash 300 Plus instrument?
So this is a, a good question for smaller injection volumes. You know, as an alternative method, instead of going through the injection valve and then having to flush it through with a solvent to make sure you know, it's all into the system and you're not missing any. What you can do is you can actually directly inject it onto the column. So after you've equilibrated the column and you've chosen liquid loading, you can actually remove that column or remove the injection valve carrier trolley and inject directly onto the column. So a lot of times if I'm doing liquid injection, especially for small volumes, I'll do it that way because that's going to get it right onto the column and minimize any band broadening just from going through the injection valve tubing. So that's a good alternative and a fairly clean way for to get sample onto the system without having to go through the injection valve.
Okay, another question. When the separation is complete, can I check the purity of each component through the peak purity, such as HPLC?
Yeah, so you can do some peak purity analysis by looking at your chromatogram or using the peak purity function if you have it enabled during the run. And what that does is it looks at the UV spectrum of that over the peak, and it looks to see how it changes over that whole spectrum. So if you have a changing UV spectrum, it's usually indicative of throughout the UV spectrum, it's going to be indicative of changing compound ratios. Obviously, this isn't going to be as precise as looking at HPLC of your fractions to look at purity that way, but it's a nice quick look. You can also take advantage and look at the UV spectra of each peak on your own, or look at if you have a pure ion hooked up to your system on the AccuPrep or the next gen. You can use the MS, look at the MS for that time point, and then see if there's any other compounds that might be in there. Just keep in mind you're also looking at adducts and fragments and other things that might be as part of the MS ionization process.
Thank you for answering that. We have another question. What's the main difference between empty cartridges and the pre-packed columns as a pre-column?
Yeah, so this is, I think, alluding to the use is maybe a guard column for C18. So both of them have frits on the bottom, so they would be filtering out anything before it gets to the column itself. So there should be no difference. There's no real difference between their effectiveness, and and protecting your reusable C18 column. So they're a good, either one's a good alternative to help, extend the life of those. Depending on your loading, like I said, if you're using C18, you could use C-Lite or the pre-packed C18. You do need to condition that beforehand, so that is an added step. But obviously, if you use the C18 or C-Lite and pack it yourself, you need to evaporate it off. So both of them have their time disadvantages and advantages. So depends on what's kind of easier or what you're more comfortable with.
Okay, we have some other questions, Josh. The next is if you solid load your sample on silica, such as 5-gram sample onto 25-gram silica, using a rotovape, doesn't that make your loading band super broad? As in you have a sample dispersed over 25 grams versus using a pre-packed solid load sample where the sample should be at the top?
That's a really good question. So visually, when we put our, if you have a colored compound and you put it on the solid load cartridge, visually it looks like it's spread out over the column, right? But we need to think about what's actually going on when it, we dry it out and then we put the mobile phase to it. So what's going on with the mobile phase and how that is a compound interacting with the stationary phase. So the way to kind of think about this and get your head wrapped around it, because visually you're right, it looks like a huge broad band. But when using the silica, what's going on is as long as your compound's not immediately traveling down the column in the initial mobile phase conditions, it's basically going to sit on the silica. It's not going to travel down. So the compound that's at the top of the solid load cartridge isn't going to start traveling down that cartridge and onto the column until you reach the correct mobile phase composition, the higher percent B. And once that happens, once you're in a range of where your K value is in 1 to 10 and you're starting to move down the column, since the conditions at the top of the cartridge are different than at the bottom, it's going to start to kind of tighten up that band because the mobile phase conditions are weaker at the bottom versus the top of the cartridge. This goes along with some other questions regarding kind of using C-Lite versus silica. And these are really good questions. And a lot of people like to use C-Lite and a lot of people like to use silica. And I think both are very effective methods. So if we think about that retention again, C-Lite doesn't retain compounds as well as silica. And so it looks like that when we use C-Lite, it kind of pushes our band down to the top of the column where then it interacts with the silica and then it basically absorbs to the top and it doesn't want to travel down until we get the correct percent B. While on C-Lite, while it's on the C-Lite, we can use a lower percent B to really get it to move down because the absorption is not as strong, that binding of the compound to the C-Lite is not as strong. So in reality, we need to really think about what's going on in the mobile as a combination of the mobile phase and the stationary phase when we load these compounds on. Follow up on that question. With the pre-packed solid load sample also, when you pre-pack that, if you're using a really strong solvent to load that on there, it's going to travel down that silica on your cartridge, depending on your loading solvent, because if that compound moves in that strong solvent, it's going to go ahead and start traveling down. You're going to see band broadening that way too. Let's see. Another question here is if your sample load, so this is in regards to the C-Lite again. So if your sample loading on a C-Lite column is about half of what you would use on silica, and so we suggested 10% loading versus 20% loading, are you more likely to get a wider sample band on the flash column with this type of loading? And based upon what I described earlier, and what we observe also when we use C-Lite versus silica in the lab is we don't really see a significant difference in the band broadening. The additional silica in the column cartridge, or the solid load cartridge, sorry, basically kind of extends the column bed, the effective column bed for the sample because you get added retention. So it just kind of pushes your compounds back a little bit in retention. But the bands are very similar, and there's not really a big difference. Another question here. So I'm trying to separate these out into the prep HPLC and flash just to get them, keep them targeted here. So one sec here. Yeah, so another question about the pre-packed loaded sampling cartridges. Could they be used with other brands of instruments, or are they only designed to be used with our instruments? The cartridges could potentially be plumbed to use with other instruments. I mean, they're designed with the lure lock to screw onto our systems, and then but you could use tubing or an adapter to connect that to tubing for another system. So you can use the pre-packed loading sampling cartridges that way. But you would need a solid load cartridge cap to do that. That would be the key piece. And then you could piecemeal fittings to get it to connect to your system, depending on what system you're trying to connect it to. Let's see. Okay, and then another question regarding the sample band, how the sample band is reduced in the solid load cartridges if we use a strong solvent in the pre-column. So just keep in mind that when we use the solid load cartridge, the ideal situation is that we then evaporate all the strong solvent off of the silica when we load it or we pack the solid load cartridge. Or if you're using the pre-packed cartridges, that you let it dry using either a vacuum oven, air, or just letting it sit in the hood for a little bit, depending on the size, so that we can get rid of that strong solvent. Once we have if that strong solvent is still on there, then that's going to be what is affecting your chromatography with your compound. That's going to allow it to travel with no retention down the column, and you're going to have band broadening and poor chromatography because of that. So that's the key, is we need to get these dry to get optimal results with the solid load cartridges. And then let's see. I think one last flash question here. And this is a really good point. So someone asked, how about large volume injections using on like a C18AQ column, flash column? They typically inject 100 milliliters or more onto a 415 gram size column, which is a larger column, and fairly significant injection volume. But because you're dissolving it in the weak solvent, what happens is when it gets onto the column as a liquid injection, is it's not going to be traveling. You're not getting any. You're getting really strong retention, so it's not traveling down the column at all. And so you'll see this a lot of times with peptides and prep purifications, prep HPLC, where they're doing really large sample injections compared to what you would see with small molecule injections, because they get really strong retention initially, and you're not loading in conditions where the compound is moving down the column. Okay, a few others here. These are going to be more prep HPLC oriented questions here. So one of the questions is, would there be a problem doing serial injections using the loop, especially when going onto a C18 column with the sample dissolved in water? And so basically, like I said, the limitation is the loop size there. So as the injection process, you're pulling the sample into the loop. And then once you fill the loop with sample, now you're going to be pulling sample into the waste valve. So that's the limitation. So you could do a larger loop if you can load more compound on that column. Just use like a 10 or 20 mil loop, depending on what kind of injection you want to do. You could swap the loops out, and that's fine. You can do that on the AccuPrep. I think the idea that they're kind of getting to here, though, is regarding stacked injections. And currently, that's not a feature that we are able to do on the AccuPrep. But it's something that, chromatographically, if you have compounds that, and under isocratic conditions, you could do multiple injections over time there during the run. You could time those out to where you could get separation that way. So, but you need, if you want to do one-shot injections, you need to get a larger loop on there. Another great question we kind of alluded to a little bit earlier. A lot of the organic compounds we like to purify, they aren't easily soluble. And that's kind of the dilemma, is how do we inject those compounds and get good chromatography still? And so, the question here is, how do you can I elaborate on the volume of DMSO to dissolve sample for reverse phase? And it's kind of a tough question because it's going to depend on your column size. So if you go to the loading guides that I showed, the charts showing the loading guides for the prep and the flash, think about what the column volume is, and the ratio of your injection volume to column volume is a good starting point. The other thing you want to consider is how well retained is my compound initially. So, if my compound's really early eluting, it's going to be more affected by loading issues. So things coming out in the, before 30% on a silica normal phase gradient, things coming out before 30% and a reverse phase gradient. Those are the compounds that tend to get pulled forward with the DMSO the most. And then they don't have time to catch up and have retention with the column because they've already been, they traveled a third of the way down the column by the time you're done loading. So think about your compound, where it's at in the gradient. You can get away with using higher amounts of DMSO if it's a late eluting compound, 30% or later, because you can still get that retention. And then also think about the ratio of your injection volume to your column volume. If you can stick to less than 5% of your column volume, I think that's a good starting point, because it's not traveling down the column too far in that pure strong solvent there. Okay, a couple more questions. Got a few here. There is going to be this won't count as one of the questions, but this presentation will be available later. It's recorded. And two more chemistry questions here. Is the bracketed sample injection only for C18, or does it work for silica columns too? That's a good question. So on the AccuPrep, this is only on the AccuPrep, keep in mind. So it's with the auto sampling and the AccuPrep. You could apply those same principles to a silica normal phase column. Theoretically, I think it would be helpful. A lot of people aren't really working in the normal phase on the AccuPrep, so we haven't really investigated it. My only concern is that if it's an early eluting compound, that initial, 1 to 2% of strong solvent in a silica normal phase separation tends to have a strong effect initially with how the silica behaves, because as you're adding that polar solvent to polar solvent to the column, your silica tends to interact with it pretty strongly initially. You get kind of a strong effect with it. So it's not something we've tested. I think you could apply some of the theory to that and get some good results. And then lastly, we had one last question here. Do you have any suggestions for peptides that have a sample amount of 2 milligrams and which mainly have hydrophobic residues? So I'm assuming this is a prep HPLC question with that scale. So with the peptides, depending on the size is important too. There's basically kind of 3 different stationary phase options that can be of value, and that are kind of complement each other. So we offer a C8 prep column that works great for peptides that are of higher mass. The other thing is, if it's an early eluting compound on your C18, going to the C18 AQ column offers a lot of advantage for some of these compounds that travel that elute early. I think in this case, though, this should be well retained on the C18 with the hydrophobic residues. So C18 would probably be an okay choice depending on the size, or the C8. And then the other thing you can take advantage of is using the focus gradient feature on the AccuPrep and kind of determining a optimized focus gradient method for that compound. So that would be a great use of that feature on the AccuPrep to kind of get a good mobile phase percent range. And then you can kind of dissolve that in whatever with that small of a load. So like I said, this recording, it will be available later. I really appreciate you guys taking the time to attend our webinar today. If you guys have any other questions, feel free to reach out to me directly at my email address. A lot of great questions and discussion today, and appreciate your guys' time. Thank you.